right? So we have understood what is the need for going towards fuzzy logic and how fuzzy logic is different in terms of fuzzy logic is different handling day-to-day applications. At the moment, looks pointer is creating some problems. So we have seen that all our practical applications are dealing with a lot of uncertainty, right? Vagueness, practical applications. And the conventional systems or conventional logic, which is based upon the Boolean logic, okay, which is based on the discrete logic, do not provide no chance or do not provide any chance to compute with words. So, do not compute with words. Yesterday we have seen a couple of examples. And also we have discussed how the conventional logic is handling the uncertainty through probability, right? We all know that we have probability theory that deals with handling uncertainty in practical applications. Also, we have discussed yesterday that the fuzzy logic is different from the probability theory. We gave one or two examples. In order to understand in a fairly better manner, let us look at this particular scenario. Imagine that somebody is walking in a desert and having and he's full of thirst. Okay? He found two bottles, right? Found two bottles, bottle A, and say take an example, another bottle, bottle B. Okay. All of you are able to follow? Are you guys listening?
Yes, sir.
Yes.
Yes.
Yeah. Yeah. So let us understand that bottle A has the label, and he can choose only one bottle. Bottle A has the label saying that the water is 0.1 probability of poisonous. Okay. A says the water is 0.1 probability of poisonous. Okay. B says the water is belonging to fuzzy set of poisonous, the membership degree 0.1. Fuzzy set of poisonous. Okay. There are two statements like this. Statement A says water is 0.1 probability of being poisonous. Okay. And statement B says water is belonging to the poisonous fuzzy set with a membership degree 0.1. Now tell me, somebody who picked these two bottles, you suggest which bottle he should drink? Bottle A,
one.
bottle B.
Sir, they should take bottle A.
We should drink bottle A.
Yes, sir.
Okay. Why?
Yes, sir.
Sir, because the probability of that being poisonous is only 0.1, But the B is surely poisonous, but it is very less poisonous.
Yeah, can you please repeat?
So the probability of A being poisonous is very low, 0.1. But the B is poisonous, but very less poisonous. Like it is only 0.1 poisonous.
Who's that said this statement?
Akil sir.
Okay. Akhil says that he has to go for A. The reason is it is probability of being poisonous is 0.1, and here the is belonging to the fuzzy set poisonous degree with the lowest value. Correct?
Yes, sir.
Okay. Any other answers? Any other answers? Remember, this is very, very important. What I am talking here, I understand, I can sense that yesterday, those who have attended have not clearly understood the difference between probability and fuzzy logic. Then I was exploring this option. So tell me, this is very, very important and it's very fundamental for understanding the difference between probability and fuzzy logic. This is a very beautiful example. Look at the two statements. And somebody said that one should drink bottle A. It is with the 0.1 probability of being poisonous. The statement B says the bottle belonging to the fuzzy set with a membership degree 0.1. Okay. Any other answers? Any other answers? Hello?
The same only for me also.
Somebody says both are same. Okay. Any other
No,
answers?
so I'm saying for me also that A option is correct as compared to the B one.
Okay. Somebody is saying that A is better. Okay. All of you are of the same opinion. Please raise the hands. Who says one should drink A? Please raise the hands. Please raise the hands. How many says for A? There are only 6, 7, 8. Okay. Now tell me who says B. Please lower down those who said A. Can lower down their hands and raise those who say B. Bottle B. Only one. Only one. What happened to others? Nandini? Nandini?
Yes, sir. Sorry, I had a net issue, that's why I couldn't hear the voice.
No issue. Don't worry. You look at the statement. So among the two statements, which bottle you suggest that the person should drink water from which bottle? Bottle A or bottle B?
From bottle. I think from bottle A, sir.
Bottle A. Okay. Okay. What do you think so? Okay. No issue. I will explain. So
Okay,
the point is, the point is, the statement A says, in bottle A, water is poisonous, the probability of 0.1. Okay. That means water inside that particular bottle is poisonous with a probability of 0.1. That means even if it is 99%, it is not poisonous, but there is a chance of being 1% or 0.1% water is of poison. A person who drinks that water, even there is a chance that with that minute probability, drinking poisonous water, right? Hello?
Yes, sir.
Yes.
1 in 1,000.
Yes, sir.
He is drinking the water which is poisonous, correct?
So there is a
with the least-
1 by 1,000 chance that it is poisonous.
Correct, but still he is drinking the poisonous water, correct?
Yes, sir.
Do you agree that he is drinking poisonous water? If
Sir,
even with that
nine-
one, sorry?
Sir, doesn't it mean that there is 1 in 1,000 chance that it is poisonous?
Correct, yeah. See, 1 in 1,000, that is the probability, but the water is poisonous, right? Hello?
Sir, there is 999 by 1,000% chance that water is not poisonous.
Correct, but that point, whatever the probability, the least probability that water is poisonous, correct? I'm talking about that.
Yes, sir, yes.
Yes,
I'm talking about the least probability, whatever you quote, in that probability, the water is poisonous, correct?
Yes, sir.
So that means the person who is drinking that water with that least probability, he is still drinking the water of which is poisonous in nature, correct? Hello?
Sir, isn't it that way for this
So
sake?
the problem
Hey,
is
yeah,
like
please
we are thinking
understand.
like
Yeah, go
we are
ahead.
thinking like it can be poisonous or it cannot be. It depends, right? So like
Correct
the
here. Correct here. See, the point is like this. Imagine in that probability, do you drink? I'm defining the probability of water being poisonous at this particular probability, 0.1. Do you still take the chance of drinking that water even with that least probability?
Uh,
You tell me,
Sir.
say yes or no.
No, sir, no.
No, you tell me, say yes or no. Do you still drink that water even with that least probability? That's a poison. If that probability becomes true, that is a poison, right? Hello?
yes,
Sir, even if that 0.1 is lethal, then I will go with A. But if 0.1 is not lethal,
Hey,
then
yeah,
I will go with
see,
B.
please, who is this? Is it, who's this explaining?
Sir, me, Akhil.
Still, please try to understand. I'm trying to explain. Please stick to the point because all others are listening. They also should understand. My question is, even with that least probability, given the least probability, given the chance, somebody has to drink, to tell me whether he has to drink it or not, because the water is poisonous, even with that least probability. Say yes or no only for that statement. Only for that statement, say yes or no. Do you drink it or not?
no, sir.
No, right? It is absolutely no, because water would be fully poison. That means water is poison there. Now look at the second statement. Second statement says water is belonging to the set of, what is that set called? Poison set. And it says with a membership degree 0.1. That means what? Water contains poison at that particular percentage. You understand? Do you understand?
No, sir. Can you repeat?
I repeat. The statement says water is belonging to the set of poisonous with a membership degree 0.1. What does it mean? It means the liquid that is there inside the bottle B, that means the water that is there inside the bottle B has poison that made that bottle belonging to the set at 0.1. That means it contains a poison of a percentage that gives to that membership value 0.1. That means what? Water contains the poison with that least percentage, correct? Hello? Do you agree that? Do you understand that statement? Shall I repeat? Shall I repeat again? Hello?
Yes, sir. Sorry, but I'm not getting the.
Okay, no issue. I will repeat. See, the point is, bottle B contains water. The statement meaning that the statement B says, water has poison at 0.1%. That's what is the meaning of that statement. Hello? Now you got it?
Sir, can you repeat again?
Again, I'll repeat.
The second
Yeah.
statement.
Second statement says, water in this particular bottle contains poison at 0.1%.
Like how we concluded. Okay. Okay.
That's what is the statement. That's what is the statement.
Yeah.
Now tell me which bottle will be, you will choose to drink. The first bottle that is having the probability of 0.1% being poisonous. That means water inside the bottle is completely poisonous. Choosing having such bottle is 0.1%. Second one is water contains 0.1% of poison. Now tell me which one you will choose to drink, or you suggest that person to drink.
Yes, sir. The second one, because in first one, the chances of getting poison is if we take off case of being poisonous, it will be 100% poisonous, and in second case it will be 0.1 only. So it B will be better, sir.
That is what, see, you must understand there is a difference between uncertainty, which is captured in the statement A, the uncertainty that is captured in the statement B. If you notice, the uncertainty that is captured in the statement A is talking about an event. What is that event? The event of choosing or having the bottle containing the poisonous water. If you look at the second statement, it is not talking about the event. It is talking about the water itself. Water having poison. What is that level of uncertainty at 0.1%? That means water has the poison at 0.1%. That means very minute. So whereas here, if you look at the first scenario, even if that 0.1% becomes true, when the person chooses that bottle, he is drinking actually poison. You understand? Whereas in the second scenario, when he chooses the bottle, he is drinking the water having a 0.1% of poison. Okay. So in the first scenario, if he chooses the first bottle, if the probability becomes true, person is drinking poisonous water. In the second scenario, person is drinking water having 0.1% poison. Okay. Now do you understand?
Yes, sir. Clear.
Yes.
First one is dealt by probability. The second one is dealt by fuzzy logic. Hello, is that clear?
Yes, sir.
Any doubts? Because this is the fundamental notion, the fundamental notion of understanding the difference between probability and fuzzy logic. We think both are same, but remember, both are dealing with totally different things in the sense that, of course, it is uncertainty. Uncertainty of choosing are getting a bottle having the poison. That is the first one, probability. Uncertainty of having how much amount of poison is there inside the water is the fuzzy logic. And based on that, you are saying, okay, how much amount of poison is there? I'm saying 0.1%. You are saying accordingly, based on 0.1%, we are saying water is belonging to the set called poison water with a membership degree of 0.1. Okay.
Yes, sir.
Now I think this is the very classical example that one can take it to understand the concept of or the difference between the fuzzy logic and the probability theory. Okay, this is very, very, very important in the sense. The reason is that generally people will think, okay, both are same, probability is same, fuzzy logic is same, or fuzzy logic is another facet of probability. No, it's all about this. Okay, in the sense, both are trying to capture the uncertainty in one way, but both actually are dealing two different uncertainties. Okay, Akhil Raj, you said something?
Yes, sir. I think it's basically the same thing.
Okay. Because I could not see the message. I got a pop-up saying that you have sent a message. Okay, so that's what is the concept. Now having understood the difference between the probability and the fuzzy set theory, what actually they deal with, okay? The classical set theory has roots, classical logic or the Boolean logic has roots in the classical sets. Okay, we all know what do you mean by set. We all know what are the various properties of the sets. Okay, so I need not define the set now because you guys know about what is meant by set and how do you define a set. And you say that an element belongs to the set or does not belongs to the set. Okay, if an element belongs to the set, you call that if it is true, and if the set, either you will have it belongs to the set or do not belong to the set. That's all. Two things you have, not more than that. There are various properties. Various properties that our classical sets satisfy, including idempotency, associativity, De Morgan laws, and we have various operations such as union, intersection. These are all the various operations that what we do it. Okay, we all know how to do that. And in addition to that, you have idempotency property. A union A is equal to A intersection A is equal to A. Then commutativity by in terms of union, commutativity in terms of intersection. Then you have associative property, you have distributive property, you have De Morgan laws. These are all the various properties of the classical sets, right? And in addition, you have some more properties. Let me keep these properties in the slide so that you can refer them when you are referring in terms of as a notes. Okay. Okay. So you can notice identity property of in terms of union, A union null set is equal to null set union A is equal to A. Then you have involution, A complement whole complement is A. And most importantly, you need to remember these two laws. One is law of excluded middle. On the classical sets that says A union A complement is equal to the universal set, A intersection A complement is null set. Okay, this is the law of excluded middle, and you have law of contradiction. these two properties you please remember, because when we are going further, when we are talking about the fuzzy sets and fuzzy logic, you will see the difference between the classical sets and the classical sets and the fuzzy sets in terms of difference in these two properties. Now, we will discuss the fuzzy set now. What do you mean by fuzzy set and how it officially looks? Before we go to the fuzzy set, let us take one typical scenario. Okay. So we are going to talk fuzzy set. Okay. So all of you are able to see the a small data set that is given.
Yes, sir. Yes, sir.
Okay. You have a family and there are various members in the family: grandfather, grandmother, dad, mom, daughter, son, auntie. Their age was given, okay, 72, 63, and their gender. Now the point is, we wanted to define a set. Okay, we want to define a set called senior family member. A set called senior family member. Can somebody tell me who can be there in the senior family member set?
Age above 60.
Sorry,
Age
Grandma.
above 60.
grandfather, grandma.
Sir, everyone except son and daughter.
Sorry,
Everyone except son, daughter.
on what basis? Everyone
Sir.
except son and daughter. That means except 5 and 6. So that means 1, 2, 3, 4. Somebody say okay, 7. That's all. Okay.
Yes, sir.
And so obviously for you, daughter and son, they are not belonging to the senior family member set, right?
Yes, sir.
Okay. So a person with age 72, he is belonging to the senior family member set. And similarly, a person with age 38 is also belonging to the senior family member set, correct?
Yes, sir.
So you have only two things: belonging to the set or does not belonging to the set. Right? There are only two things, right? Anything else you have? Any granularity is there?
No, sir.
No granularity at all, right? So only, and certainly there are two individuals who are not belonging to the set. Now, imagine I don't want like this, and I don't have even those among them who are belonging to the set. I don't have I don't have a logic, or I don't have the means with which I distinguish the grandpa and as well as mom. Okay, he is 72 and 38. And now tell me, first of all, how do you say that 1, 2, 3, 4, 7 are the belonging to the set?
Sir, everyone except the youngest generation.
No, you don't tell youngest. I'm talking about taking a quantitative metric called A.
Sir,
And based on
18
that, I'm
plus.
talking.
Sir, 18 plus.
18 plus. Okay. So if age is 18 plus, that's what you are mentioning, right?
Yes, sir.
Okay. Now, imagine if I define a rule like this. So I don't want the set to be like this. Rather, I want a little granular approach of defining the set. My senior member set. The granularity is I'm saying if the age, imagine this X is age. Okay. X is age. I'm saying, so your senior family member is the set called A. Okay. So your senior family member set will have the individuals, but with a varying membership degree. with a Merriam membership degree. That means a gradual approach. It will not say that if you are age above 18 plus, you are belonging to, if you are below age 18 plus, you are not belonging to. Okay, I don't want that. But instead, I want a kind of a granularity in the sense, if a senior person of 72 is there, you assign a membership value. A person with 41, you assign some membership value. You assign for a member with the age 38, assign some membership value. But somebody may ask, what is the rationality of having the membership value? That is based upon by defining a membership function. This is my membership function. That says if X is less than 30, it is 0. If age is between 30 and 70, my membership value is X minus 30 by 40. If age is above 70, above greater than or equal to 70, my membership value is 1. Okay. This is how I defined my membership function. Remember, I keep saying this is the membership function I defined. Somebody may say, no, sir, I want to define the membership function in a different way. No issue, you can define. Okay. But let us, for now, we will go to that argument a little later. But now you understand this is how I defined the membership function. With that, what is going to happen is that my set of senior family members will looks like this. Okay. My set of senior family members looks like this. Is that table visible?
Yes, sir.
Yes, sir.
At the table. It says the grandfather belongs to the senior family member set. I'm calling it as A, with a membership value 1.0. Because if you look at my membership function, maps age 72 to membership value 1. Similarly, my grandmother with age 63 belongs to the set with a membership value 0.8. My dad with the age of 41, as per this membership function, he belongs to the set with a membership degree 0.2. And my mom belongs to the set with a membership value again 0.2. Of course, daughter and son, as per the membership function, their membership values are 0. That means you can call that as they actually do not belong to the set, or they belong to the set with a membership degree 0. My aunt with the age of 52 belongs to the set with a membership degree 0.5. Okay. Is that clear?
So as the age of daughter and son is less than 30, so the result will be negative. That's why we have taken them 0, right?
So you see the way I have defined the membership function. Okay. My membership function says if X value,
okay,
that is
got
the
it.
age value is 15, it is 0. Right?
Yes, I
So
got it.
now when I write my fuzzy set, it looks like this. All of you please carefully understand. My grandpa belongs to the fuzzy set. Remember, I'm writing with their serial number. I don't have the space, so I'm writing with the serial number. 1 belongs to the fuzzy set, belongs to the set A with a membership degree 1.0. My grandmother belongs to the set with a membership degree 0.8. My dad belongs to the set with a membership degree 0.2. My mom belongs to the set with a membership degree 0.2. Daughter, 3, 4, 5. Yeah, daughter belongs to the set A with a membership degree 0. Son belongs to the set with a membership degree 0. aunt belongs to the set with a membership degree 0.5. This is my set. This set is called fuzzy set. Okay. Look at the difference between this fuzzy set and the classical set. If you look at the classical set, it is telling you, number one, somebody is belonging to the set and somebody does not belong to the set. Even among those who are belonging to the set, you don't have the option to capture to how much belongingness, what is the strength of their belongingness to the set. Look at the case here. I'm saying grandpa is belonging to the fuzzy set with the membership value of 1.0, whereas mom and dad are senior members with membership degree or membership value 0.2. Is that clear? The difference between classical set and fuzzy set?
Yes, sir.
Hello?
Clear, sir.
Guys, those
Clear, sir.
who have not understood. Okay, these are all very fundamentals. If there is a little problem in understanding, your entire fuzzy logic, fuzzy set theory understanding would go wrong. I don't want that to happen. Please
Sir,
raise the hands, those who have not understood. Otherwise, if you have a doubt, you please ask. Yeah, Akash.
sir, how we define that function mu a equal to x minus 30 by 40? Like,
That I will tell. Yeah. That I
okay,
will tell.
and for fuzzy set, we just mapped the value of mu with the corresponding family member, right?
Okay. Yes.
Okay.
I'm writing the fuzzy set. If you look at the classical set, you are writing set elements 1, 2, 3, 4, 7. Here also it is an element, but element has not just element, but its membership degree. Okay. That is how you have to write your fuzzy set. Okay. You cannot write simply element, but the element membership degree should be written. In the fuzzy set. Hello? Is that clear?
Yes, sir.
Now, somebody has asked a doubt, sir, how you have written this membership function? Okay. The another major advantage of having the fuzzy logic case is I am saying that for me to define a senior family member, I am defining with this is my membership function. Okay. Somebody may define it in a different manner. Like, Akash may define it in a totally different manner. He may say that, I'm going to say that my senior family member fuzzy set will have the membership function, it would be like if x is less than 15, I'm going to define it as 0. Otherwise, I'm keeping some granularities, right? So here, if you notice, there are only intervals such as less than 30, between 30 and 70, and above 70. We may write it as like, x is less than or equal to 15, then between, the 16 and say 45, then between 46 and 60, you understand? And similarly between 60 and above, 61 and above, you understand? He may define it his own set, membership function. Hello?
Yes, sir. We can define our own membership function.
That's all. You can define your own membership function. And remember, it's not that you randomly define. It also depends upon the context, right? Say, take an example. When you say that, of course, this is based upon, for a humans, we are saying senior family member, right? Now imagine that you are taking this to some other universal set. So the universal set is the humans, right? Okay. Look at a scenario where imagine you take it to some pet dogs or pet animals. There their you know their lifespan. Accordingly, some animals may imagine that they live up to the age of say 30, and obviously you have to define the membership function like aged animals or middle-aged animals or whatever it is. So take an example, when your universal set is different, you change your membership function. Okay, are you able to follow?
We should define the membership
Yes,
function in
sir.
such a way that it should look rational, right?
Exactly. Again, so the point is this: you are saying rational, right? The rationality varies for every individual, right? So you may say that, look, why I should go with 30, I'm going with 15, I'm going with the 20. So as long as that is rational and you justify it, so you define your membership function, right? So that is the flexibility provided by the fuzzy logic and fuzzy set theory. And the fuzzy logic and fuzzy set theory is able to do that because of the membership function. Okay, the beauty is that. The membership function. Okay. And what you need to understand from this example is that when you are comparing that fuzzy set with the classical set, number one, classical set, you are saying that the member is belonging to or does not belong to. That's all. But whereas in the case of fuzzy set, you are saying that they are belong to, but with a varying membership degree. Now you go back to the first statement that what we have given. Water is poison with a membership degree of 0.1. On what basis? The amount of poison that is there in the water. Okay, the amount of poison that is there in the water. Obviously, this is less harmful for an individual. Water with having 0.1% of poison is less harmful rather than choosing a probability even with 0.1% drinking completely poisonous water. Okay, is that clear?
Yes, sir.
Hello. Hello, yeah,
Yes,
is that
sir.
clear?
Yes, sir.
Thank you. So
Clear.